Good morning, students. This is your RJ sir. Today we are going to discuss about bond order concept. So within fraction of seconds, how to find bond order, what is the original concept about bond order, what are the properties of bond order, we'll discuss completely related to IIT JEE and NEET exam tips. Okay, we'll start the class immediately. Please note all these things. It is very helpful to your coming competitive exams. Okay, we'll start the class. See here, what is a bond order concept? So, before going to know about bond order, we have to know very important concept about that is MOED. MOED. What is MOED? Molecular orbital energy diagram. What is MOED? Molecular orbital energy diagram. So this is here MOED, molecular orbital energy diagram. So here M means molecular, isn't it? What is M? Molecular, isn't it? So and and O means orbital and E means energy and D means diagram. So molecular orbital energy diagram. Clear, right? So that is here MOED concept. MOED concept. So we'll discuss completely about this concept clearly. All of you concentrate here. Yeah. This is today's what we are going to discuss. Important uh, questions they are asking based on the bond order. See this. This is insights. What is this? First, what is the MOED of N2 and MOED of O2 and bond orders of N2 O2 and properties of bond order, and we also find here this one O2 O2 plus O2 plus 2 O2 minus 1 O2 minus 2. Similarly, nitrogen also we are going to discuss. Similarly, we are going to discuss about nitrogen bond orders and other molecules bond order also we are discussing if possible. Otherwise, we'll go for one more video. Clear, student? Yeah. Now we'll see all of you concentrate here. Look at here. So this is here MOED, molecular orbital energy diagram. Clear? What is molecular orbital energy diagram? All of you concentrate here. See, this is here energy order. What is this? Energy order. This line indicate what? Energy order. So that is here lower energy level to higher energy level. Similarly, I put one more here, one more line that also indicate here energy from lower energy level to higher energy level. In this diagram, you can see here, this is here one atomic orbital, one more atomic orbital. These two atomic orbitals, what happen you see? See, I am explaining here. These two atomic orbitals, okay, these two atomic orbital, yes, come to this page. Yeah, these two atomic orbital that is AO and AO both combined and form here BMO bonding molecular orbital, and sometimes excess electrons also enter in anti-bonding anti-bonding molecular orbital electrons. So here this is called what? MOED diagram. What is this? Simply we can say MOED diagram. So whatever electrons are there in atomic orbitals, atom orbitals, they are enter into molecule. That is called your bonding molecular orbitals. And opposite of this one, we'll go for here anti-bonding molecular orbital. So this energy diagram we have here, least energy is bonding molecular orbital, followed by atomic orbital, followed by anti-bonding molecular orbital. This is the energy order of our atomic orbitals, bonding molecular orbitals, anti-bonding molecular orbitals. Clear, sir? So this diagram we can contain here 1s orbital of atomic orbital here. So this 1s orbital, and also we have here Also, we have here see 1s orbital. These two atomic orbitals contain two electrons. These two electrons are filled here and here, and these two electrons are we have totally four electrons. These four electrons we can fill here first initially least energy according to Ohm's rule. We need to pair the electrons, isn't it? And according to above principle, first least energy level, then highest energy level. So we can go for a least energy BMO, followed by we'll go for anti-bonding molecular orbital. See, like this, we can fill the total four electrons in first bonding, then followed by anti-bonding. So this is small diagram. We can understand what is a molecular orbital energy diagram. So this molecular orbital energy diagram will give you simple sense that so electrons are entered in BMO first, then followed by ABMO. So this is simply we can say MOED diagram. So in this MOED diagram, yeah, just now what we discussed, energy order is important. So which is the highest energy? See, which is highest energy? Anti-bonding molecular orbital, which is least energy bonding molecular orbital, followed by a atomic orbital. Atomic orbital. Okay. Now we'll discuss one example to understand what is the full complete details about MOED diagram. MOED diagram. See all of you. See, I am taking here MOED of nitrogen. MOED of nitrogen I am selecting. What I am selecting? You can see MOED of nitrogen I am selecting. So nitrogen molecule, how nitrogen molecule is formed. How nitrogen molecule is formed. See, I will explain clearly what is the information about nitrogen molecule first. All of you see this. All of you see this one. Here we will discuss nitrogen molecule. Nitrogen molecule. See this, all of you. In this nitrogen molecule, nitrogen atomic number 7. Electronic configuration is 1s2, 2s2, 2p, C7, 2 plus 2, 4 plus 3. This is the electronic configuration. Also, we can write here 2 comma 2 comma 3, or we can add this to 2 comma 5. This is also electronic configuration. Electronic configuration. So we know these are here. This is 1s2 electron, 1s2, 2s2, and 2p3. Like this, we are taking here n2. N2 means n plus n. So two atoms we are taking. That's why I am showing you here. You can see one is n2, another is n2. So one this is electronic configuration of nitrogen 1s2, 2s2, 2p3, and same 1s2, 2s2, 2p3. Clear? 2p3. Now these are here involving in the LCAO. So what is LCAO? Yeah, we'll discuss that one also. What is LCAO? LCAO means LCAO means LCAO means see this. All of you concentrate here. I'm explaining. All of you concentrate here. LCAO means LLC. Only yeah. LCAO means L means linear. C means combination of of atomic orbitals, atomic orbitals, atomic orbital. Clear? So that is it. What is meaning of linear combination? That is, we can take your hand, two hands. You can see your two hands. Two hands are we can incline one to other. That is little finger to little finger, and thumb to thumb, and middle finger to middle finger. Like this, we can how we are combining. Similarly, here also we are combining that 1s orbital to 1s orbital to 1s, see, 1s orbital to 1s orbital of another nitrogen, and similarly 2s orbital to 2s orbital of another nitrogen atom. Similarly, you will go for 2p3 orbital to 2p3 orbital of another nitrogen. This is called linear combination. Linear combination. This linear combination we can observe in the nitrogen molecule. Nitrogen molecule. See this, all of you. What is a linear combination? Linear combination of atomic orbital. Atomic orbitals. Atomic orbital. Clear? So that linear combination of atomic orbital we are discussing here completely. All of you concentrate here. Very important. Very important. See this diagram. This is here. MOED of N2 diagram. What is this? MOED of N2 diagram. We are discussing MOED of N2 diagram. What is this diagram? MOED of N2 diagram. Here also we can take here similarly here see energy order least energy to highest energy. Also you can draw another line here. If you want you can draw here one more line. Otherwise not required. One side is enough. One side is enough. Now we'll go for this. See what happens. Come from down to up. Down to up. Yeah. See this is here 1s2, 2s2, 2s2, 2p3, 2p3 of one nitrogen. One nitrogen. This nitrogen. Clear? And one more nitrogen is there. That is. So what is that? And one more nitrogen you can see here also 1s2, 2s2, and 2p3, 2p3. So like this. So these are here. Simply we can say MOED of N2 diagram. MOED of N2 diagram. Clear? Now how to fill the electrons? Be careful. How to fill the electrons here? How to fill the electrons here? See, concentrate. Here 1s2 electrons. Here also 1s2 electron. Total 1s2 plus 1s2. Totally 4 electrons are there. That 4 electrons we need to fill here first BMO. See 2 electrons are here. 2 electrons here. Clear? So totally this below one is called BMO, bonding molecular atom. Also we can indicate here sigma 1s2. Sigma means sigma bond can form between these two atoms. One sigma bond is formed. Clear students? So between these two atoms, one sigma bond is formed means that meaning of here one is a sigma bond, remaining are maybe pi bond. Like this we can understand. So one sigma bond is formed. Therefore, that sigma bond is we can indicate in the form of sigma symbol. So here all of you see this. So nitrogen we are discussing. Which molecule we are discussing? Nitrogen atom we are discussing. So nitrogen and between nitrogen and nitrogen atom, one sigma bond is formed. That is we can say sigma. So that is here sigma 1s2. Sigma 1s2. Clear change? Sigma 1s2. Similarly, upper one anti-bonding molecular atom, you can say sigma star 1s2. Star is nothing but to identify which is bonding, which is anti-bonding. That's it. Okay. Similarly, 2s atom, 2s2, 2s2, totally 4. So 2 electrons in bonding, 2 electrons in anti-bonding. Totally 4 are completed. Here also sigma 2s2, sigma star 2s2, 1s2, 2s2. All are over. Now come to that next one. Here also we'll get here one more bond is formed. So based on this, we can go for here 2p3, 2p3 orbital. That is here we can see in the diagram 2p3, 2p3 orbital linear combination we are explaining. So linear combination of these 2p3, 2p3 what away. So 2p3 means here 2px, 2py, 2pz. Clear? Do you know this? 2px, 2py, 2pz. So like this we have here one is here 2px, this is here 2py, and this is 2pz. Similarly here also 2px, 2py, and 2pz of nitrogen atom. Nitrogen atom, all atoms. Now these three electrons we can fill one electron each. One electron each. See we fill like that one electron each. Based on this one electron each, one electron each of atomic orbital over. Clear? Atomic orbitals are over. Clear? Now we can discuss how these electrons, total 6 electrons filled in the bonding. See here, we can fill one electron first, isn't it? First one electron, followed by one more electron, and again one electron, followed by one more electron. Then 4 electrons are over. Remaining we have 6 electrons. So remaining 2 electron, upper one of this orbital, that is 2px orbital. These are can form pi bond. Therefore, we can say pi 2py or pi 2pz. Here sigma, that is nothing but here 2px 2. You can two electrons are there, now we can show here 2. Here 2 electrons are there, now we can show 2. 2 electrons are there, now we can show 2 like this. So here why you are taking pi? That is important. See, just now we discussed here. Na? So whenever one is sigma bond, another is what? Pi bond. So one more pi bond also possible. So two pi bonds, and one sigma bond is formed in this MOID diagram. So see the That is a 2py, 2pz, 2 pi bonds are there. Clear? Remaining up to here 6 electrons are completed. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Clear? So all electrons are completed. So nothing is there in this. Nothing is there in this. So leave it as it is. Empty. Clear? So this is here our MOID diagram of nitrogen. We'll check again. Yes. See this? We are writing here electronic configuration. I am going to explain again. Be careful. All of you listen. So MOID of nitrogen. So nitrogen electronic configuration 1s2, 2s2, 2p3. So we can write 2, 2, 3. So that is totally we have here two atoms, nitrogen plus nitrogen, N2 we can write. So that is here electronic configuration of nitrogen 1s2, 2s2, 2p3, 1s2, 2s2, 2p3, 1s2 to 1s2, 2s2 to 2s2, 2p3 to 2p3. That is LCAO, linear combination of atomic orbital. Based on that, I take here diagram. See this? First I am taking here 1s, 2s, 2p3, 1s, 2s, 2p3, and remaining are here as it is we fill. So total electrons here 2 plus 2, 4. So up and down 4. Here also 2 plus 2, 4. Up and down 4. Here also 6, 3 plus 3, 6. So 1, 2, 3, 4, 5, 6. So all are completed. So based on this diagram, what we can find, what we learn, that is very important. Now we can see here come to this page, very important. We can observe the diagram also. I will use a space for both. Yeah. Now you can, are you able to see properly? Yeah. Now all of you concentrate. All of you concentrate here. See what happened? Here, first of all, we need to find electronic configuration. What we can find here? Electronic configuration. So electronic configuration of this molecule we can find by using this one. So how to find electronic configuration of this molecule? What is this? EC means electronic configuration of what? Molecule. Electronic configuration of molecule we are discussing, student. What are we discussing? Electronic configuration of N2 molecule. Which molecule? N2 molecule we are discussing. So what is the electronic configuration? Now all of you concentrate. See, electronic configuration from the MOID diagram only. Electronic configuration from the MOID diagram only. How to find this? See, actually we have electronic configuration of atom 1s2, 2s2, 2p3. Yeah, here also 1s2, 2s2. This is atom. But what is a molecule? Molecule means middle one. See this one. 1s2, 2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma, sorry, 2p, pi 2py2, pi 2pz, and 2px2. That is here electronic configuration of molecule, not atom. So that we can write here. See, first one sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 lesser than, that is lowest energy to highest energy we are moving now. Like this we can move upward. So that is here we are writing. Yeah. So like, so that is here next one pi 2p y2, both are in the same level. See in the diagram, both are in the same level. These two are same level, these two also same level. When they are same level, not up and down. For example, one is here, one is here. That is up and down we can see. But both are same level. This having same energy level. Therefore, we can write in the electronic configuration also. These two are equal. These two are equal. Clear, students? So these two are equal. So and followed by lesser than sigma 2px2. So total electrons are here. 14 electrons are there. Yeah, we can generally we can find 14 electrons in the nitrogen. That is 7 plus 7 is equal to 14. Yes, that 14 are there. Now what is the remaining importance in this? Okay, electronic configuration we find. Then what? Yes, then what in, bond order. Very important. This is our concept actually. We can find the bond order of these molecules, diatomic molecules, by using this. Clear? What is the bond order formula? Half into bonding molecular orbital electrons minus anti-bonding molecular orbital electrons. Bonding means down, anti-bonding means up. So okay, so this is the difference. So bonding minus anti-bonding minus anti-bonding will get the bond order. We can see here. So this is your bonding molecular orbital is equal to half into how many bonding. Yeah, we can check it out. How many Bonding means down. So here 2 electrons, here 2 electrons, 2 plus 2, 4. Here 6 electrons. Totally how many electrons? 6 electrons are there. So totally we have here 6 electrons here and 2 electrons there, 2 electrons there, and remaining 2 electrons here. Totally how many electrons here? 10 electrons. So come here. So 10 electrons. And anti-bonding how many electrons? Anti-bonding means here 2 electrons are there, here 2 electrons. That's it. Totally 4. Upon here you can see nothing is there. 0, no electrons because totally 14, 14 are filled, 14 are filled. Therefore, you can see the formula. So bonding 10, anti-bonding 4. Bonding 10, anti-bonding 4. Therefore, 10 minus 4 is equal to what? 6. So 2 1 jar, 2 3 jar. We'll get here answer is 3. So what is the meaning of 3? That is important here. What is the meaning of 3 here? What is the meaning of 3 here? Tell me. What is the meaning of 3? Yes, anybody? That is nothing but between nitrogen to nitrogen. Nitrogen to nitrogen. Here, how many bonds are there? That is 1, 2, 3 bonds are there. How many bonds are there, student? 3 bonds are there. That three bonds indicate bond order. Bond order 3. That is bond order 3 means between two atoms, 3 bonds will be present. That is the importance of our bond order concept. Any doubt in this? What is the bond order? Number of bonds between two atoms. What is the bond order? Number of bonds between two atoms. So how many bonds are there between two atoms that indicate what? Bond order. Clear? Any doubt in this? Okay. Last one, magnetic properties. What is the magnetic property? Whether this nitrogen molecule is diamagnetic, means it is not attracting any other molecules, or paramagnetic, means it is attract other molecules. That we'll discuss now. See here, no more unpaired electrons in the molecular orbital diagram of nitrogen, isn't it? Therefore, it is diamagnetic substance. Diamagnetic substance. We'll check in the diagram. See by the diagram this much of information you get. See in an atom of nitrogen, all of you concentrate. See in the atom of nitrogen, atom 1s2, 2s2, 2p3. See here three unpaired electrons are there. In the atom, we are discussing in the atom. So atom, nitrogen atom is paramagnetic. Nitrogen atom is paramagnetic. Clear students? Because it contains nitrogen atom is paramagnetic, whereas nitrogen molecule is diamagnetic. Why diamagnetic? Because in nitrogen molecule, no unpaired electrons. You can check it out. No unpaired electrons in this. See here, two electrons are paired. 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 Here also two electrons are paired. Here also two electrons are paired. All are paired. So that is why here it is diamagnetic in nature. Diamagnetic in nature. Clear, students? This is the information about our nitrogen molecule. Nitrogen molecule. Any doubt in this? Any doubt in this? Clear? Yeah. Now we'll see. Now we'll see how to predict the bond order. This is our concept. How to predict the bond order. How to predict the bond order, isn't it? So we can find the bond order of this molecule. How to find bond order of molecule? How to find the bond order of the molecule? You can see very important concept this one. How to find within fraction of seconds? Within fraction of seconds, we can find for seconds we can find this answer. For second we can find the answer. How to find? Yeah, you can see. For example, just now we draw all the diagram, all these things. Now not required. Within fraction of second we can say the answer. How? How? Yes. Nitrogen contain total number of electrons are. Tell me how many electrons are there? Yes, nitrogen 14. So 14 electrons are there. So what, sir? Yes, bond order is equal to 14. We can write like this. 14. We can write like this. How can you write? See, I am explaining here how to write 14 here. 14 you can write like this. Yes, all of you concentrate here. How I am writing to the 14? All of you concentrate. All of you, this is important. This is very important concept. See, How I am writing here 14. So nitrogen, for example, they are given nitrogen for you. Nitrogen for you like this. Okay. Nitrogen. What again? Yes, nitrogen is given like this. Okay, student. Then we can say total number of electrons N2 plus N2, N2 plus N2. That is nothing but what? 14. So that 14 we can remind in our mind 10 minus 4 by 2. That's it. 10 minus 4 by 2. If it is 15, if it is 15, then if you have 15, just we can write 10 minus 5 by 2. Clear? If it is for example, 16, then you can get the idea here 10 minus 6 by 2. So this is a way to get the shortcut within a fraction of seconds. We'll see it is possible or not. You can find or not bond order. All of you concentrate how to find the bond order. Yeah. See this N2 bond order 14 10 minus 4 by 2. So what is answer? 3. So that is just now what we discussed. Bond order is 3. Clear? Bond order is 3. Now we'll go for here O2. We don't know what is the O2 diagram, but we can find bond order. Now what is this? Total electrons are 16. How 16? Oxygen plus oxygen. So oxygen atomic number 8. Here totally bond order is 16. Right. Here oxygen, one more oxygen. Oxygen atomic number 8. 8. 8 plus 8 is equal to what? 16. So 16, how to write? 16 is equal to 10 minus 6 by 2. So that is answer is 2. So what is the meaning of this? Oxygen, oxygen contain, our oxygen contain, isn't it? Our oxygen contain two bonds. Two bonds. How many bonds? Two bonds. Isn't it? Don't forget this. That's why bond atom is 2. O2. O2. Similarly, come to this O2 plus 1. Yes, easy. In a chemistry, plus means minus, minus means plus. Common sense it is. Chemistry, we can say plus means mostly we are taking addition, minus means we can take a subtraction. But generally in the chemistry, this is exactly opposite. Exactly what I mean. Opposite we are taking. But what we are taking in a mass, this is differ. This is differ. Clear? Don't forget this. What is the difference between these two? Yeah, you can see here. Anything is, for example, O2 minus 1 is given. You can take minus means in chemistry plus. O2 means how much? Just now it is 16. So we can add 1 for this. Then we'll get here 17. What will get? 17 after addition. Same O2 plus 1 is given. O2 plus 1 is given. Then we can take here O2 means 16 now, plus 1 means in chemistry you can take minus. That is nothing but 15 is your answer. So it is common for all. So O2 plus means you can subtract 16 minus 1, 15. 15 means 10 minus 5 by 2. That is nothing but 10 minus 5 by 2 is 5 by 2. That is bond order is 2. Similarly, O2 plus 2. So plus 2 means we subtract 2 electrons. Isn't it 14? 14 means equal to nitrogen. That is nothing but 3. Similarly, O2 minus. See within fraction of seconds. Minus means plus 17. 17 means 10 minus 7 by 2, that is 3 by 2, that is 1.5. Clear? Fraction of seconds. O2 minus 2, that is 16 plus 2. So that is 18. 18 means 10 minus 8 by 2, and that is 2 by 2, that is 1. So now we can see this question is asked so many times in mains and advanced and all competitive MSET and NEET exams. What is the correct order of this one? You can see order. This is bond order just now calculated 1. See this here is 1. So this is here 1.5, 1.5, and this one is 2. Yes, this is 2. This is 2.5, 2.5. This is 3. So this is the correct order, not? This is the correct increasing order. Which order it is? Increasing order. So increasing order of O2, or that is oxygen bond orders. Bond orders. Clear? So like this, so many times asked this question. So thank you very much. And how we'll get why we are taking 10 minus 2? I know you got a doubt. Okay? I know I know you got a doubt. Sir, why you are taking that is 10 minus 2? Yes, there is a super logic. We'll discuss, I will explain in next class. We are taking more example for this. So why you are taking here? Sir, here we are taking, for example, 16. 16 means you are taking 16 as a 10 minus 6 by 2. How it is possible? Yes, we'll discuss in the next class. Okay. I will explain clear full details. Thank you very much, and please subscribe my channel and follow me for more details. Thank you very much.